are watching Junior Certificate Mathematics lesson, and we are looking at Revision Mathematics Paper 2. In this paper, you are allowed to use a calculator, so you should have with you a set of mathematical instrument and a calculator, because those are the resources that you will need as you'll be working out this paper. And we are looking at past examination questions to help us in our revision. Let us have a look at those questions. The first question says, the diagram below shows a triangle A and triangle B. Use it to answer questions that follow. So this is the diagram that you are having. You have triangle A and then triangle B. So it says you are to use this diagram to answer the questions which will follow. The first question, that is A, says triangle B is the image of triangle A under a transformation. Then it says describe the transformation fully. So all that you are told is that triangle B is the image of triangle A after a certain transformation, and then you are expected to describe the transformation. Now, there are 4 transformations that you should know. We've got what we call enlargement, and then when you describe enlargement, you state the scale factor as well as the center of enlargement. And then we have reflection. To describe reflection fully, you state the equation of the line of reflection. And then there is what we call translation. To describe translation, you state the vector of translation. And then we have rotation. And to describe rotation, you state the center of rotation, angle, as well as the direction of rotation. So these are the transformations that we expect that one of them will be represented in the 2 diagrams over here. So let's have a look at the diagrams and check which of the transformations has been used to map A onto B. The point here, when we check translation, this cannot be translation, rotation cannot be rotation, and then when we check enlargement, this is not enlargement, so it means we are left with reflection. And then if it's reflection, it means for us to describe reflection fully, we need to state the equation of the line of reflection. And let's remember, the line of reflection is basically the mirror line, so it has to be midway between the 2 triangles. That will be the line of reflection. So we have triangle A and triangle B, and then upon a closer look into this, we can see that the line of reflection will be the line cutting the y-axis at, that will be the line of reflection there. It has to cut the line will cut the y-axis at 2. So that is the line of reflection. So if you are to describe this fully, it means we'll have to state that this is a reflection, and then the line of reflection, it's a reflection under the line y, it's equals to, what is the line of reflection? We need to check y equals to 2. So this is a reflection under the line y is equals to 2. This is how we describe reflection. You state the transformation. So the transformation here is reflection. And then how do we describe reflection? The reflection is described using what we call the equation of the line of reflection. And according to this question, the line of reflection is y equals to 2. That's how we describe reflection. And then B. Triangle B is translated onto triangle C by vector -5, 2. So we are told that this is a translation using vector -5, 2. And then it says draw and label triangle C on the grid above. So we are to draw the triangle C using vector -5, 2. So how do we draw this triangle then? Let's check. It says triangle B is translated onto triangle C. So we are to translate triangle B. This is our B. Under translation, every point on this diagram will move the same distance in the same direction. So we are told to translate using vector -5, 2. If you are to pick this point here, we'll move 5 steps to the left. 1, 2, 3, 4, 5. And then 2 steps up. So it means the point will be here. It means our point will be here. That is 1, 2, 3, 4, 5, and then 2 steps up, 1, 2. That's where the point will be. And then what about this one? 5 steps towards the left hand side, and then 2 steps up, 1, 2, 3, 4, 5, and then 2 steps up, 1, 2. The point will be here. And then this one, 5 steps left hand side, 1, 2, 3, 4, 5, and then 2 steps up, 1, 2. The point will be here. So that's the vertex of our triangle. And then all that we need to do is to draw the line joining these 3 points. So the line will be drawn from this point up to this, and then draw another line using a ruler up to this one, and then the last one will be a line drawn from this point here up to this. So this is the image of triangle B after translating using vector -5. The translation vector is -5, 2. So we have to translate this using -5, 2. -5, 2. And we have done exactly that. And we have to label this as C. So this is how we translate. All that you need to do is to make sure that every point on the diagram move the same distance in the same direction. And upon translating triangle B onto C, all the points moved moved 5 steps to the left and then 2 steps up, because that's the translation vector that we were expected to use. And then let us have a look at another question. Question number 2. Question number 2 says, the diagram below represents the position of airports A, B, and C. That's the diagram that we're having. We are told that it's airport A, B, and then C. And then the question says, you are to calculate the size of angle ABC. This simply means you are to find the angle at B. Before we can work this question out, let us go for a short break. When we come back, we'll start working on this question. We are at a situation where we are to calculate the angle at B from the diagram here with us. And what we have is we got the triangle ABC, and then we are expected to find the angle at B. That is this angle here, X. That's what we are expected to find. And also, this is a right-angled triangle. Now, when given a right-angled triangle, it's either you use the Pythagoras rule to answer questions, or you can use the trigonometric ratios. So here, we are going to apply the trigonometric ratios because it says we are to find the angle at B. And then how do we find this? We apply the SOHCAHTOA. It says the sine of an angle is opposite over the hypotenuse, cosine of an angle is adjacent over hypotenuse, and then the tan of an angle is opposite over the adjacent. And then what about angle B? Which of these can we apply? If we check the sine says opposite over the hypotenuse. We don't have the hypotenuse here. It's not given in numerical value. And then what about the cosine? Cosine of an angle is adjacent over hypotenuse. So still we cannot use the hypotenuse because it's not given. And then what about the tan? The tan of an angle is opposite over the adjacent. So we have the opposite and then the adjacent. Here, the opposite is 400 kilometers and then the adjacent is 700 kilometers. So we can use the tangent ratio, which says the tan of angle marked X is equals to the opposite divided by the adjacent. So as per the question, the opposite is 400, so this means it will be 400 divided by the adjacent. And then what is the adjacent? The adjacent is 700, so it's 400 divided by 700. And then the 0 here will cancel this one, the 0 here will cancel this. So all in all we have 4 divided by 7. 4 divided by 7 is not angle x, it is the tan of angle x. So to find the value of x, it will be tan inverse of 4 divided by 7. And then all you can do is to punch your calculator, find out what the tan inverse 4 over 7 is. You are now to find the value of x. And to find the value of x, you need to take the tan inverse of 4 divided by 7. And upon taking the tan inverse of 4 divided by 7, x, which is the angle, x is equals to 29.74. And then we need to remember that angles are written correct to 1 decimal place. So this will be 29.7 degrees. This is how we write angles. Angles are written correct to 1 decimal place. It's different from all these other numbers where we use the 3 significant figures. When it comes to angles, we express answers to 1 decimal place. So the value of angle x, which is angle ABC, is 29.7 degrees. And then question number B. Question number B says, what is the bearing of airport B from airport A? So we are to find the bearing of airport B from airport A. Let's go back to the diagram because that's what we are using. The question says we are to find the bearing of airport B from airport A. That is, we are to find the whole of this angle here. We have 20 here, so we are left with the angle here. But remember, angle x is given as 29.7. That is, angle x is 29.7 degrees. And the sign here is saying we have the angle at C here as 90 degrees. So to find the angle at A in the triangle ABC, we simply add 90 and 29.7. Then subtract from 180. That will answer the part which says what is the bearing of airport B from airport A. So we have 180 degrees minus 90 degrees plus the 29.7 degrees, and then we close. This will be 180 degrees minus, what is 90 plus 29.7? We can add that and then find out what the answer is. 90 plus 29.7. The answer is 119.7. So we'll write 119.7. And then when we subtract this from 180, what will be the answer? So subtract from 180. It's 180 minus 119.7. The answer is 60.3. So this is 60.3 degrees. And then what is the 60.3? The 60.3 is the angle at A in the triangle ABC. So this angle here, it's equals to, what's the value that we got? It's equals to 60.3. So the angle here is 60.3. So that's what we have. But the question says we are to calculate the bearing of B from A, meaning we are to find the whole of this angle from the north line up to this. And then how do we get this? It will be the 60.3 plus 20 degrees. That's the bearing of B from A. The bearing of B from A, bearing of B from A will be equals to the 20 degrees plus 60.3 degrees, and then this will be 20 degrees plus 60.3 degrees is 80.3 degrees. So the answer is 80.3 degrees. This is the bearing of airport B from airport A. We simply need to add the angle at A, in this case is 60.3, and then the 20. This will give us 80.3 degrees. And remember, we are saying this is the bearing of B from A. So that means we are to work at the angle located at A. We are working on the angle located at A. That is 80.3 there. Question number C says, calculate the distance between airport A and airport B. So you have to find the distance between A and B. So let's go back to the diagram here, because that's our point of reference. It's A and B. So it says you have to find distance AB. And then how do we find distance AB? We have the diagram is like this. This is our point C, this is A, and then this is B. The angle here is 90 degrees, and then here is 700, here is 400, and then you are expected to find AB. So how do you find length AB? This is a right angle triangle, so we are expected to find the hypotenuse. How do you find the hypotenuse in a right angle triangle? To find the hypotenuse in a right angle triangle, all that you need to do is to apply the Pythagoras rule. The Pythagoras rule says the longest side, if you are to call this x, then x squared will be equals to 400 squared plus 700 squared, and then x will be equals to the square root of 400 squared plus 700 squared. 400 squared plus 700 squared. Take your calculator, work out what 400 squared is and then what 700 squared is. 400 squared. 400 squared plus 700 squared. 700, not 7,000 but 700. It's 4,000, not 4,000 or 400 squared plus 700 squared. And then what is the answer? The answer is 650,000. So we are saying x is equals to the square root of 650,000. That is the value of x. And then take the square root of 650,000. So we have this. Then what will be the square root of this? The square root of this is 806.22577. It's 806.22577. So you can just write this as 806.22. We calculated x and we found that x is equal to the square root of 650,000. So we are to take the square root of 650,000. And when we take the square root of 650,000, the answer is 806. It's 806.2. We can just write 806.2. So this is simply saying x is equals to 806.2, which approximates to x will be equals to 806. It's just 806 to 3 SF. And remember, this was given in kilometers. Yes, this was in kilometers. So this will simply mean the distance between A and B is 806 kilometers. So all that we can write is the length AB is equals to 806 kilometers. So this is the distance between A and B. It is the distance between airport A and B. All that you need to do to answer this question is to apply the Pythagoras rule. And remember, the Pythagoras rule says the longest side squared is equal to the sum of the two shorter sides squared. So that's how we find the length AB, by applying the Pythagoras rule. What about question number 3? It says express the following as a single fraction. So you have 3 over x plus 2 minus half. So you have to express this as a single fraction. The question is 3 over x plus 2 minus half. You need to start by finding the lowest common multiple of x plus 2 and 2. And then how do you find the lowest common multiple of x plus 2 and 2? If you have, say, 2 over 5 plus 1 over 4, all that you need to do to find the lowest common multiple is to look for to multiply the 5 and 4, and then the lowest common multiple will be 20. So even here, you are simply going to multiply x plus 2 and 2. So the lowest common multiple of x plus 2 and 2 is x plus 2 times 2. This is the lowest common multiple of x plus 2 and 2. So x plus 2 into x plus 2 is 2. Then 2 times 3 is 6. Minus 1. And then you need to introduce the brackets, because the minus 1 here is going to multiply everything inside the bracket here. So 2 into 2 is 1. That means you are remaining with x plus 2. So x plus 2 times negative 1. We have to make sure that we include x plus 2 inside the bracket. So this will be x plus 2. Close the bracket. This will simplify to 6 minus x minus 2. It's minus 1 times x is minus x. Minus 1 times positive 2 is minus 2. The minus 1 here is multiplying everything inside the bracket. And it's very important that you take great care of this. Don't just multiply x and negative 1, forgetting that 2 is also to be multiplied by negative 1. And this is to be divided by x plus 2, and then the 2 here. We don't have to open up the brackets for the denominator. Just leave it as x plus 2 times 2. You don't have to open up the brackets for the denominator. And this will be 6 minus x minus 2. Collect the like terms. Minus x plus 6. Because the sign for the 6 here is a positive, so it's plus 6 minus 2 divided by x plus 2 times 2. Then simplify. Minus x, 6 minus 2 is 4, so it's positive 4. So it's minus x minus x plus 4 divided by 2 times x plus 2. This is how we express the given question, in this case 3 over x plus 2 minus half, as a single fraction. And upon expressing this as a single fraction, we got minus x plus 4 divided by 2 times x plus 2. And other questions of this kind, you should be in position to work them out. But before I let you go, let us have a look at the summary that I'm having here with me. It says, remember to always have with you a set of mathematical instruments and a scientific calculator when revising paper 2. It is important that you have a scientific calculator, because this is what you will be using. In paper 2, you are allowed to use a calculator. So you must have with you this scientific calculator. And then also, it is important that you show your working to avoid losing marks. If you don't show your working, instance where you are going to write answers and then you expect to get full marks, you will end up losing marks. It is very important that you show your working in all these questions. From me, till we meet again in the next lesson, goodbye.